solving two-step equations. Let's go take, for example, the equation 3 times b minus 11 equals 4. You want to solve for b, so in order to do that, you have to do the inverse operation of what is happening around b. So instead of minus 11, we add 11, and it zeroes out the minus 11. Now we can take the 3b down on the left side. On the right side, we have to balance the equation and do the exact same thing. So we add 11 and we get 15. Now to cancel out the 3, we do the opposite and we divide and we get 1b. We do the same thing to the other side. 15 divided by 3 is 5. And there's our answer. It's always important in math to check your work. So if b is in fact 5, then we get 3 times 5 minus 11. 3 times 5 is 15, and when you take away 11, the answer is 4, which matches what it says on the right side. So yes, our answer is definitely correct. Good job. Now let's consider the equation negative 10 plus 2 times r equals negative 4. Now we want to isolate the r so that we can find the value of what r is equal to. So let's look at what's happening around it and let's undo all of the operations. Let's go start with negative 10. In order to undo or do the inverse, we add 10 and it zeroes out the negative 10. Balance the other side by doing the same thing and you end up with 2 times r equals negative 4 plus 10. So if you owed $4 and you took out a $10 bill, you would be left with $6. If 2 times r is equal to 6, then we divide by 2 and we find that r is equal to 3. And now once again, here we are checking our work. We believe that the answer is r equals 3, so we substitute the 3 where the r goes and we get negative 10 plus 2 times 3. Now that gives us negative 10 plus 6, and if we calculate that, check our answer. Do we get negative 4? Yes, we do. This tells us that r equals 3 is correct. For our third example, let's go consider some division and if our variable is on the other side. So here we have 7 equals c divided by 3 plus 5, and we're looking for the value of c. First, we're going to deal with the 5 and do the inverse by subtracting it. I went ahead and did it on both sides, and it zeroes out on the right. We bring down the c divided by 3 on the right, and on the left, 7 take away 5. Okay, that's simple. That's equal to 2. Now, what number divided by 3 is equal to 2? You cancel the 3 by multiplying, and that gives us 1c. And when you do the exact same thing on the left side, you get 3 times 2, which is equal to 6. So we find that c is equal to 6, or in this case, 6 is equal to c, which is the same thing. Okay, let's check out our work. So we have 7 is equal to 6, which we substitute for the c, over 3 plus 5. 7 is equal to 2 plus 5, and yes, 2 plus 5 is equal to 7, so our answer is correct. Fantastic. For our final example, let's go challenge ourselves a bit. We have the quantity j minus 10 divided by 7 is equal to 7. Now, since that whole numerator is being divided by 7, we have to get rid of the divide by 7 first. So we're going to go ahead and multiply by 7, and it cancels out the denominator 7 because 7 over 7 is 1. That leaves us with j minus 10. Don't forget, that's called doing the inverse operation. You do the opposite. Also, remember, we have to balance the equation on the other side. So on the right, we multiply by 7 also, and that gives us 49. So now we have j minus 10 is equal to 49. Let's go fix that up. Now, what number minus 10 is 49? Well, if we do the inverse and add 10 to each side, it cancels out the minus 10, and we find that j is equal to 59. Now let's go check the answer for our last example. If we think j is 59, then we substitute it for j, and we get 59 take away 10 over 7. That gives us 49 over 7, which does indeed match the 7 up top. So that tells us that our answer is correct and j is equal to 59.